Hey, and welcome to Entraz here. In this video, we're going to have kind of a series look. We're going to have a lab where we're going to look at networking and we're going to talk about VMs. We're going to start with a Cisco 3560CX. Basically, it's a layer 3 switch. This thing is going to provide the layer 2 access to our servers, and it's also going to provide, of course, layer 3. It's going to provide access between servers, between the VMs on the servers, and of course our PC. So yes, we're going to have a PC connected to that as well. But we're going to have two Supermicro servers. Basically, we have a one RU box that has two servers inside of it. Each of these servers are going to have 2 NIC each and an SSD. On top of that, I believe we're running the old Intel X series CPUs. So on top of these servers, we are going to be running ESXi, which is a VMware bare bones hypervisor. On top of this, we're going to run, of course, Microsoft Windows 2022. And this is going to have domain services as a domain controller and DHCP. Once this is done, we're also going to have a VMware vCenter server where we can talk about central management for our 2 ESXi hosts, and of course how to create clustering and other various central options. You may ask yourself, what is a network? Well, technically it's just a bunch of devices and a bunch of software that allow people to work. You can't work without servers, and you can't work without information. These devices and this software provides that ability. And we're going to be talking a little bit about that here. Little introduction. When creating a network or a lab, you must have specific requirements. And this really goes for anything in the IT world. If you need to do something, well, you need to figure out what you need to do that thing. Here we'll answer some of those questions about what a network is and create a simple lab to run networking, physical servers, virtual machines, Microsoft Windows, Active Directory, DNS, and of course the network-based DHCP that'll give access from my computer to my servers. There are a lot of options. Taking the time to figure out what you need to move forward with allows you to learn and the potential to start a career, giving you the first steps to be in an IT networking and systems administration. We are Entraz. Check out our website, www.entraz.com, N-T-R-A-A-S. In the networking realm, we do have a lot of options when dealing with networking. This video is going to be pretty simple in terms of networking, as we're only going to be able to look at a layer 2 and a basic layer 3 routed switch. There are many options out there, the 93, 94, 9600 series Catalyst to the Nexus line. But we're going to sit with a small 3560 for the moment. We're going to be looking at IP addressing, DHCP, VLANs and what they provide, especially in a hypervisor environment, and of course local routes, because we only have a single networking device. Switching. IP communication starts with a MAC address. This address is hard-coded on every network interface card or NIC. Like your house and your street, the MAC address provides a destination to reach you. Secondly, you have an IP address. This would work more like a city, state, and country. In order to get from one city to another, you kind of need to know what direction to take, which roads to take to get there. Once the packet leaves one city, it makes it to another, and you need to figure out, okay, well, the street address will get the packet the rest of the way, the same way the MAC address will. When we look at the ARP tables and the MAC address tables, you'll understand a little bit more about the difference between IPs and MACs at layer 2. Layer 3 routers and Layer 3 switches tell each other their connected IP addressing. Once the packet gets to the last Layer 3 router, it will map that IP address to a MAC address in the ARP table and find where to send the frames from there. As an example, port gig 14 will have the MAC address of my laptop mapped to that port. The IP address will map to the MAC, and the MAC will send the frames out port 14. Without a network, your servers really can't serve. As I mentioned before, you can have all the computers in the world, but if you're not on the internet, well, you can't do much outside of your computer. You can't gain access to anything. So we really need the network to be able to work. When looking at our systems, well, of course, I'm using Supermicro for this example. Like your computer, a server runs an operating system. In this case, the servers are going to run VMware's ESXi operating system. ESXi has been purpose-built to extrapolate the physical hardware and provide those resources to virtual machines. Things like CPU, RAM, video cards, hard drives, SD cards, USB devices, keyboards, and the mouse. There are a lot many more items that come with physical to virtual hardware, and we can get into that in a later video. For ESXi hardware, ESXi allows us to create virtual machines utilizing local hardware resources, as we mentioned previously. VMs require the use of virtual hard drives, or the VMDK file. This provides storage to the virtualized operating system, such as Windows, Linux, vAppliances, etc. Using things like 72, 10,000, and 15,000 RPM spindles will only provide a certain speed, especially with regards to seek time. When you have spindles, the data is written to a circular device. This circular device has to spin in order for that head unit to find and read that data. And of course, moving parts takes time to access it. Running an SSD or NVMe devices will decrease that seek time and increase the throughput allowed for the VMs significantly. So anytime you have the ability to run an SSD or NVMe as your physical hard drives, it's probably a good idea. So each VM requires CPU resources as well. The number of physical cores will allow you for more CPU or CPU cores within a virtual machine. Keep in mind that if a VM has 4 vCPU, it will consume 4 physical CPUs of that physical host when they are needed. The speed of the physical CPU will also have an impact on performance of the VM. Each VM, of course, requires RAM, so the speed and amount of RAM will affect both the amount of RAM the VM can have as well as the speed of memory for that particular VM. Here's a couple of statements here. My server has a 7K storage spindle, 2 16-core 32-thread CPUs at 2 GHz apiece, and of course 64 gigs of 2300 MHz RAM. The next one has an SSD storage, but it only has 8 cores and 16 threads, but it's running at 3.2 GHz. So the question here is, well, which one would be faster? I mean, you have to take certain things into consideration. A 16-core at 2 GHz versus an 8-core at 3.2 GHz, a 7K spindle versus an SSD. Well, these are some of the questions you need to iron out. One of the big answers, of course, is, well, the VMs will be faster when it's accessing data or accessing VRAM, something like that. SSD is a lot faster, and there's no seek time. For the CPU speed, well, sometimes you'll have an application that runs on a single CPU, so it's not symmetrical processing. Other times you might have an application that will utilize multiple cores. So if you have an application that requires a high gigahertz core, Well, even though you have 16 cores and you can give more cores to that virtual machine, the application probably won't utilize it. On the 8 cores, you can give it less cores, less threads, but it's got a faster CPU range, 3.2 versus 2. So when you're dealing with virtualization, you really need to look into what you're actually going to serve. Does it require a faster processor, or does it require more cores, or both? Today, you can get a CPU with 64 cores, but you're limited to, say, 2.2 gigahertz. If you go down to 4 cores, you can get up to like 3.8 gigahertz. So it really depends on the application. As far as looking into Active Directory and DNS on Windows Server 22, Active Directory provides a central management and database for most objects on a network: computers, users, groups, certificates, domains, sites, etc. One of the things we really need to be aware of is DNS, the mapping of a name to an IP address. As an example, vCSA67.ntras.com will map to this IP address. ntras.com, dc1.ntras.com, timpc1.ntras.com. If any of these services or applications require a name to be used, such as vCenter Server Appliance, you really need to have DNS entries. As I mentioned, the vCenter server requires DNS, so you must be able to map your vCenter server name to its IP address. You also need vCenter to be able to contact ntras.com and dc1.ntras.com if you're going to use Active Directory as an authentication or identity source. So we'll need to add DNS entries for vCSA67. So the vCenter Server Appliance, or vCSA, is a Linux-ish based server utilizing the Photon VM Created Virtual Appliance, or VAP. Can only be deployed on an ESXi host. vCenter allows for many configurations and, of course, many options. Here we'll simply discuss how vCenter allows central management of all ESXi hosts and allows us to create a cluster of these ESXi hosts. A little backstory or info: a cluster of ESXi hosts allows us the ability to run DRS, or the Distributed Resource Scheduler, basically balancing resources between physical servers. HA, or high availability, in case we have one physical server fail, our VMs will be able to be migrated and restarted on another system. vSphere replication, vMotion, which allows VM migration between physical hosts, storage migration, allowing us to change where those VMDKs and other VM configuration files are stored. vCenter also allows us to create templates with VM host customization, updating of ESXi, and of course things like distributed switches, etc., etc. We have a lot of options when it comes to vCenter. Here's just a quick little switching pictograph. From one of the pictures and potential videos you'll see later, we have two servers, server 1 and server 2, that are going to connect to our 3560. My PC will also connect to this 3560 and will have a DHCP pool on it so the PC can get an IP address. Server 1, ports 1 and 2 will be a teamed trunk, server 2 the same thing, and of course PC1 in VLAN 100. Remember, a trunk link allows all VLANs to traverse that trunk link. So ports 1, 2, 3, and 4 will be for our vhosts, and we'll create our port groups with VLAN IDs on those virtual hosts, and the trunk will allow that communication accordingly. We will have the 10.0 network subnetted to VLANs 10, 10.1, 13, which is 13.1, 90, which is 90.1, and 100, which is 100.1, all as their gateways respectively. So when we see that and we give a default gateway of our ESXi hosts 10.0.10.1, well, that's the default gateway because that's the VLAN on our switch, and we'll be going over that in our first video coming up. So just so you are aware, we're going to be doing a single switch, a single routed switch here, so we don't have to do any advertised routing. However, what we're going to see is on this 3560, we're going to have VLANs that have IP addresses assigned to them. Like I said before, 10, 13, 90, and 100. Since these are all local VLANs, the IPs are going to live on this switch. Now imagine you had two separate switches. One here is for servers, and one here is for computers, and potentially you have other servers you want to have on this particular switch. You'll have IP addresses based on the VLANs here and here. If you want to allow those IP communications between the switches, you have to use some type of application to provide that, such as ERGRP or OSPF, RIP, and of course static routing. We do this a lot, of course, with default routes, and then we can add them into the dynamic routing protocols if necessary. As I said, we only have a single switch, so we're not going to need to do this. But when you start adding extra switches and you start creating more and more subnets and VLANs, you really have to understand. Let me fix this really quick. Kind of mess that one up. EIGRP. So like I said, using one of these protocols will allow us to transfer from one to the other. So as an example, we'll have 10.0.10.0/24. Let's just say this is going to be our data center. 10.0.13/24, 10.0.90/24, and 10.0.100/24. Now these are all going to be local on this switch. This is going to be our data center, and this might be our branch as an example. Over here on our branch, we may have 10.1.0.0/24. So the branch and the domain controller are not going to know how to get to one another until we add that dynamic routing protocol or static routes to tell them what the next hop should be. So we'll have an interface here, an interface here. Technically, we usually use a /30 because it's a point-to-point. So I guess as an example, 10.0.0.0/30. We'll have 1 on the DC and 2 on the branch. The next hop here will be 10.0.0.1. The next hop for DC to get to the branch will be 10.0.0.2, and they'll be able to route between one another. We'll get into some more of this dynamic routing and more expansive stuff in some of my later Cisco or Juniper videos, so we'll check that later. Anyway, that's it for this PowerPoint. Stay tuned for the next video. We'll be talking about configuring our 3560CX switch. And then the video after that, we'll be talking about installing ESXi. So hopefully you stay tuned for those, and we'll see you in a bit.